Okay, let's keep going. What about short answer questions? So short answer questions require only short, approximately 2-line answers. They test your understanding of general principles or meaning of qualitative results, and they can be combined with calculate questions. The command words you might expect to see are explain, describe, suggest, predict, plot, sketch, or draw. And some examples would be explain why, describe how, suggest why, plot a graph of, draw the mechanism for, whatever. Again, in your specification, for some of these short answer questions or things you might be asked a short answer question on, you'd be looking for phrases such as students should understand that, blah, blah, blah. If they say, if you're expected to understand that something about something, you should be able to explain it. That's where the explain comes in. You might also see students should know that, which feels a little bit more like a state, but a description can also be used as a recall. So you need to know that the color changes, whatever, orange to green, whatever. And you may also even have students should be expected to explain the process of blah, 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 blah. So those are the kind of things you can look for in your specification. So if they've asked for explain, you need to give step-by-step logical reasoning for why data or experiments show what they show. Look at the number of marks you've been given. If they've asked, if it's a 3-mark explain, you need to make sure you have explained it to level 3. You make sure that you have given 3 marks worth of explanation. Don't just state one thing and think you can get 3 marks for it. Make sure it has 3 levels to it or 3 parts to it to get 3 marks. Give a well-developed line of reasoning which is clear and logically structured, obviously. So, for example, explain why sodium oxide forms an alkaline solution when it reacts with water. Because this is an explain and not a suggest or justify or an identify, I know that this will be somewhere in my specification in some form. What would we put? Can't spend too long on it, I'm afraid, but what happens? For example, sodium oxide contains O2- ions which react with water to produce OH- ions. The number of dotted lines, okay, we said this before, the number of dotted lines given for the answer is indicative of the length of answer expected for the question. We were only given 2 lines here. We only need to give a short answer, or a short answer is all that they're expecting from us, let's say. You might be asked to suggest or predict. This is an application of knowledge. These are the questions I mentioned already. You can take a breath and just go, right, this is not content I'm expected to recall. So I need to figure out what content I do know that I can apply to this question. Okay, Personally, I find suggest or predict questions very difficult because my brain automatically goes, right, I need to be able to recall something then, don't I? What do I know? What do I know? And it can be quite difficult to filter out the information that is expected of you. So application of knowledge questions are hard, but you don't need to be able to directly recall things for it, but you do need to recall theory to apply to it. You must determine which topic is related to the information and then apply the relevant knowledge. Yeah, good. Often information or context that is not on the syllabus is provided. There should be at least something, even if you can't identify it immediately, there should be at least something that is telling you the new context or the new content. If any new information is necessary, they will give it to you. Exams are, I know it doesn't feel like it sometimes, but they are, a lot of time is spent writing exams and making sure that as much information as possible is given where needed and that the expectations are in line with your specification. So you should be given information if it's needed. Suggestion questions often include another command word, for example, suggest an explanation, suggest a name, suggest a description, etc. So here's an example. The entropy change of solution of K2SO4 is positive 225 joules per Kelvin per mole. Suggest, in terms of the states of the particles involved, why this entropy change is positive. So context, entropy. Specifically, my command word is suggest. So I have not been given this exact context, but I do have theory to be able to work out what's going on. And specifically, I'm looking at K2SO4. Solution of K2, the entropy change of solution of K2SO4, and it's a positive value. So why would it be positive? So it's only worth 1 mark, but they've given us a lot of space for it. So that suggests to me that I might need maybe a slightly longer sentence to give my answer. An answer we could have given would be potassium sulfate is solid, it's ionic, so it's going to be solid at room temperature, meaning it is ordered and has a low entropy. Solids are ordered and have low entropies. When we dissolve them, so this is entropy change of solution, something going into solution, entropy increases as it dissolves as ions become less ordered in solution. Lovely. 1 mark. What about plot? And I'll say again, we will send over the answers. So if you haven't managed to write something down, unfortunately, we don't have time to spend too long waiting for on answer slides. So we will send over answers so that you can double check and write it down anything or correct anything that you need to do. So what about plot, sketch, draw? Picking the right axes and scale are the toughest parts. They are hard. Practice these, as it's easy to think you know how to draw graphs and to skip them when revising because they're boring, aren't they? They take forever and they're hard work. Or maybe you like drawing graphs. Brilliant if you do. I personally don't. But it's a really good idea to practice them. Practice makes you faster and less likely to make mistakes. They are what I'm going to call easy marks. I know they're not actually easy, but they're easy marks in terms of it's the same thing every time when you're drawing a graph. You do have to make sure you've got the right axes, the right scale, and that you're filling the graph paper to more than 2/3 of what you've been given. And then just make sure you're plotting as neatly as possible. For example, this question asks us to plot a graph of 1/time on the vertical axis against concentration of iodide ions. So context, these are 1/time versus concentration graphs. The command word is plot, so I need to make sure I'm being nice and specific, trying not to be too slow, etc. And my direction is I've been given those points to plot. Let's make sure, though, that I'm plotting the right ones. I've been told what to plot. 1/time on the vertical axis against concentration on the horizontal axis. So make sure that you're using the correct bits of data from the table. So 1/time is over there. Concentration is over there. So those are the ones I need to use. I don't want to use time in the middle. The middle column, I'm not interested in to plot this graph. I don't have time to plot it now. We're already running out of time, so I'm really sorry, but I'm not going to have a go. But hopefully you could have a go at plotting your graph, and then I assume you would use it in the next part of the question, but we've not shown that.